Sen yap, sen yanında yapsın. Yap. Hello. Good good afternoon everyone. Good to see you all here. We have 5 people so far, so we're just going to chill until we hit 10, and then once we hit 10 people, we'll get started, or at least close to 10. If you have any questions on the culminating or anything like that, please let me know now, and then I'll answer those questions in the chat. If not, just chill and relax for around 2 to 3 minutes, and then we'll get started. The sheet you should have printed is section 6.3, and it's about transformations of logarithmic functions. Essentially, if you've already kind of understood how to do transformations for like quadratic functions and all that other stuff, then you'll be fine for this one. Especially because I find that transformations for harmonic functions like trig functions are much harder, in my opinion. Alright, we got 6 people so far. 6 people so far. Just gonna wait for a couple more people. Just gonna show the screen here. So this is what we have going on. So please have this sheet ready if you don't already, and then hopefully we can get this done and over with. I don't think it'll take too long. I think it should be fairly quick. So we'll see how it goes. So far it looks like we're still at 6 people, but I don't want to wait any longer. Hopefully we will try to get some more people on time. So let's talk about our function here. Okay, let's talk about this function here. So looking at all the transformations, you'll notice all the numbers are the same as the ones you've touched upon before. You should know what A means. You should know what K means. You should know what D means. You should know what C means. All of these are the same exact transformations you've done on previous functions. So you should understand A is the vertical stretch or compression. And we know that it's dependent on what the value of A is. If it's a negative number, it's going to be a reflection in the x-axis, or a vertical reflection. If it's greater than 1, then it's a vertical stretch. And if it's between 0 and 1, a decimal between 0 and 1, a fraction, it would be a compression. So these rules, you'll notice, stay exactly the same as they have before. The rules don't change. For K, it's the same idea. You should understand that you know it's a horizontal stretch or compression. So when K is negative, it's a reflection in the y-axis or a horizontal reflection. If we know that K is greater than 1, then it's compression. And if we know that K is between 0 and 1, we know it's a horizontal stretch. So same exact rules, nothing has changed. And of course, D and C are exactly the same as well. D is a horizontal translation and C is a vertical translation. So no new concepts here, right? And that's the thing about advanced functions. Everything that we've done or you've done in the course before, we're just kind of reapplying every single thing that we're doing in the context of new functions that I'm introducing you to. So you've done it with quadratic functions, you've done it with trig functions, and now we're doing it with logarithmic functions. So the concept, once again, is exactly the same. We're just applying it to a new function. So what happens when we apply it to this new function? So the main thing we want to know, you'll notice we have log base 4 2x. So if I ask you right away what would be the transformations on here, we automatically know we're looking at a log x as our base function, our parent root function, and so we want to look at the 2. So that 2 is what's making it different, and that 2 is going to be a horizontal compression by a factor of 1/2. Now, once again, the question that I get the most is how do we know how to do these questions, or how do we know how to plot it? And so let's talk about, especially when we look at logarithms that do not have base 10, how are you able to plot these? Because we can't use a calculator, but we do have to remember that this can be shown here. So if we have log base 4 of x, we should be able to understand if this is equal to y, right? Then we should be able to understand that we can convert that like such, right? So depending on what the value of y is, we should get the value of x, right? And we're using this because we can calculate exponential functions. We can't calculate logarithmic base functions that are not 10. So we're going to use the exponential and kind of flip it. So when we have xy here for our parent function here, our root function with no transformations, we're saying that if y is -2, then the 4 to the power of -2 should be 1/16. And so we have that one there. Then we have -1 for y. Then plugging it in here, 4 to the power of -1 is 1/4. And then if we put in 0, if y is 0 here, then x is 1. Next we do 1, then it would be 4, and if we do 2, then it would be 16. So hopefully, so far that makes sense. Okay, hopefully so far that makes sense. Now to find out the transformed points, once again, we said there is a horizontal compression by a factor of 1/2. So we understand that it'll be a 1/2x and y. So the y values we can just all keep the same. So I'm just going to draw all the brackets here to save time. And we know that there's no transformations on the y value, so we can quickly just write down those values. All we have to do is take these numbers and divide it by 2. So this would be 1/32, 1/8, 1/2, and then 2, 8. And there's our points for our log base 4 2x function. So plotting this out as best as possible. A 0, 2, 1, and then 3, 4, 5, 6, 7, 8, 2. So far we have this portion, which we can draw with an arrow. And we have to understand that a base logarithmic function, just log base something of x, will have a natural vertical asymptote at x equals 0. So there is an asymptote at x equals 0. And yeah, it's going to be difficult to draw 1/8 and 1/32 for x. So we're just going to approximate it as best as possible with an accurate sketch. And that's kind of what we're going to end up with here. Okay. So what's our asymptote? Our asymptote is going to be x equals 0. And that makes sense because logarithmic functions cannot make 0. It's impossible because exponential functions cannot equal 0. So that's where that comes from. The intercepts, any intercepts that we see, there's not going to be a y-intercept because of that vertical asymptote. So we do have an x-intercept, and our x-intercept is going to be 1/2, 0, which is our point right here. So normally for all natural logarithms of different bases, they will always have a x-intercept of 1, 0, but depending on compressions and shifts, that intercept point may change, and there's our change there. Domain and range. So domain, where x is any real number such that x is greater than 0. Because our asymptote is equal to 0, everything on the right of that asymptote exists for the function. And for the range, there's nothing restricting our range, and so therefore y is an element of the real numbers. Okay? So, are there any questions in the chat so far with what I've done? Any quick questions? If there are no questions, I'll move forward with our next one here. Okay. All right. I don't think I see any other questions, so let us move on. For this next one here, right, I'm going to write out our base function, which is log 2 of x, and we can convert that into as to 2 to the power of y is equal to x. So this is what we're going to be using to plot our points. So we have x comma y first. Let's not look at the transformations just yet. Let's first work on our original points that we have to transform from. So our y values, once again, let's do -2, -1, 0, 1, 2. And so plugging these values into here, 2 to the power of -2 is going to give me 1/4. 2 to the power of -1 is going to give me 1/2. 2 to the power of 0 is 1. 2 to the power of 1 is 2, and 2 to the power of 2 is 4. And so there we have our values. This one might be a little bit easier to plot because we have kind of much easier x values to work with. But we are not plotting these ones, we are plotting the transformed function. So now we have to look at how are these points going to transform. So we look, first we look for stretch and compression. That's the first thing you want to look at. So is there a horizontal stretch or compression? No, there's nothing here. Is there a horizontal shift, translation? No, there's no brackets on the x, which means there's no horizontal translation either. So we can actually just say that we are keeping x. For the y, we have a vertical stretch of 2, so we can write that out first. And then we have our vertical shift down by 4, so -4. And there we have it. So 2y minus 4. So once we have that written out, we can now apply those changes. So the x value is going to stay. And then we're going to do -2 times 2 is -4, minus 4 is -8. Then we continue onwards. The x value will stay. -1 times 2 is -2, minus 4 is -6. And I think you're going to understand where this is going. So we can kind of just continue onwards. And there we have it. If we were to add one more point, we can add one more point. So let's just do that because we want 1 point above the x-intercept. So let's do that. So we're going to get 8, 2. So now we can plot our points. 1/4, -8. So -8 would be down here. So 1/4 maybe somewhere here. And then 1/2, -6. Somewhere there. 1, -4. And then 2, -2. 4, 0. and then 8, 2. Okay, so now we can just kind of draw that out. And there's our graph. And you can see we still have a vertical asymptote of x equals 0. There's no horizontal asymptote. We can assume that that's going to continue onwards. So x equals 0 will be our asymptote. So that's not changing. We now have a new x-intercept of 4, 0. There is no y-intercept because of the vertical asymptote there. Domain and range. So domain, we have x is any real number such that x is greater than 0 because the asymptote has not changed. And then for our range, that has not changed either. Y is going to be any real number or an element of the real numbers. Right, so these two examples were pretty simple, like, oh, yeah, I know how to do that. Like, this is the same stuff we've done before. We're just doing it again. Absolutely, you are correct. We're doing the same stuff. What are the transformations? How does that affect our original points from the base function? Okay, so there we have it. Let's go to our second page here. We have 2 more examples, as well as understanding the transformations. So here, I'm going to have to zoom out a little bit so I can fit everything onto the screen. Okay. Let me know if this is too small as if I when I zoom out. We have f of x is equal to negative log base 3 of x minus 1. So once again, on the left side, let's work with our base function, which we know as log base 3 of x is equal to y, which means 3 to the power of y is equal to x. So we can draw our table here. Let's work with our table, which we have xy. So from our original functions, we should get 1 over 9 is equal to and negative 2, 1 over 3, negative 1, 1, 0, 3, 1, and then 9, 2. And there we have it. So that's our original function using our exponential from our base function. Then we look at the transformations. Let's look at the horizontal transformations first. Are there any horizontal transformations? Yes, we do have a horizontal translation to the right by 1. We do not have anything over here that indicates a horizontal stretch or compression. So first off, I'm going to write x plus 1 because that is true. We know that it's shifting to the right, so we're going to add 1. For our vertical transformations, all we have is a vertical reflection or reflection on the x-axis. So that's just going to make our value of y negative. And there we have negative y. And so continuing onwards, we can now apply these transformations accordingly. And so that's going to give me 10 over 9 is and 2, 4 over 3 and 1, 2 and 0, 4 and negative 1, and then we have 10 and negative 2. So the values seem pretty different. Let's take a look at where are there any changes with any of our actual values here. I think some of you may already know that something may have changed. For those that don't, let's first kind of plot it out. So I'm going to start plotting out 2, 0, 4, negative 1, and then 10, negative 2. 5, 6, 7, 8, 9, 10. And so we have our point here. And then let's try to plot 4 over 3 as best as possible. So 1 and 1/3 and 1, so maybe somewhere around here. And then 10 over 9, comma 2. So that's still greater than 1, and so it'll be closer to the point to 1 there, but not quite. And then we're going to connect our points as best as possible, going up this way. Now you'll notice how I did not shift it past x equals 1. And the reason for that is because of the horizontal translation. If our horizontal asymptote was originally at x equals 0, then shifting it to the right by 1 will cause the asymptote to also shift to the right by 1. And so as a result, that is going to change our asymptote to x equals 1. And so technically, we should see a vertical asymptote coming down here at x equals 1. I know it's hard to see because it's black, but that should be our vertical asymptote there. Our x-intercept is now different. It is now just 2, 0. We still don't have a y-intercept because the horizontal asymptote of x equals 1 is not allowing it to have one. However, if now you understand that there is a horizontal translation to the left, past x equals 0 over to the negative numbers, you will most likely have both x and y intercepts. So please make sure you understand that that is a possibility. Domain and range. So domain is going to be a little different this time, but not significantly. We're still going to write x as an element of real numbers, but now this time x is greater than 1. And for our range, we have y is an element of the real numbers, but nothing else is changing there, since there's no horizontal asymptote to stop our y from expanding on to both sides. Okay. Now for this one here, we are running out of space, but let's kind of work with what we have. So I'm going to say here log base 10 of x equals y is what we're working with. So we're working with 10 to the y is equal to x. So I'm going to do that in black down here. So this will be for C, and then this will be for D. Okay. So x comma y, let's start with that. And so we have -2 and 1 over 100. 1 over 10 is -1. 1 is 0. 10 is 1. And then 100 is 2. So these are much bigger values that we're working with. Now here, what are the transformations? And should I figure out the transformations right away? No, absolutely not. You should absolutely not be figuring out those transformations right away. And that's because whenever you have a horizontal stretch compression as well as a translation in the bracket, you must common factor out the horizontal compression or stretch. As a result, that will change what your horizontal translation will be. So this is technically not that. We're going to work with f of x is equal to log base 10 of -2 bracket x plus 2. And that's our actual function here. That's what we're working with. So you always have to remember, common factor out the horizontal horizontal stretch or compression to get the proper horizontal translation. So now that we have it, we can say, oh, there is a horizontal reflection, so reflection on the y-axis, as well as a horizontal compression. So we should keep that in mind as we write down our transformations here. So it's a compression by a half, and there's going to be a negative with an x. And then what's the shift? Oh, the shift is a +2, which means it's to the left, which means it will actually be a -2 for our point. Our y value has no changes, so we can keep it. So just quickly doing the math here, because it's going to be annoying as we have 1 over 100, 1 over 10, and so on and so forth. So just to quickly show you the math here, you're going to get negative 401 over 200, comma negative 2, because the y doesn't change, negative 41 over 20, comma negative 1. Then we have negative 5 over 2, comma 0. And then this one is negative 7 over 1, and then negative 52 over 2. Okay, so there's our values. We can really only plot like 2 of these points to be completely accurate. But before we even do that, let's figure out what our asymptote is. This time our asymptote is now x equals negative 2. Because of the shift left by 2, we know that our asymptote will now be shifted to the left by 2. Not only that, we know that there is a horizontal reflection, which means something that was facing right is now facing left, which means we still won't have a y-intercept. We will have an x-intercept as shown in the chart table there, which is negative 5 over 2 comma 0. So let's plot those points out. Negative 5 over 2 is 2.5. So there's our first point there. We have negative 7 comma 1. So negative 7, we have 3, 4, 5, 6, 7, and then 1. That's going to go that way. And then negative 41 over 20 in decimal is negative 2.05. So that's pretty close to here. And then negative 401 over 200 is going to be negative 2.005. And that's probably going to be even closer to that point there. So our best guess would be that the graph really hugs that x equals negative 2 asymptote there, right? So we're going to have an asymptote that goes down here. And so our domain is going to change now because we've had a horizontal reflection or reflection on the y-axis. We can now say that x is going to be less than negative 2, right? Because it's now going to the left part of the function here. The range is not going to change. Y is going to be any real number. So I think you guys are now going to be able to get the hang of this. Okay? So far, once again, not many significant changes or not many new concepts. We're just applying the same stuff that we've done before. So now our final last question for our lesson today. State the transformations needed to turn this first function into the second function here. So how do we do that? Well, looking at our first function, let's copy it down. We have 4 log of x minus 4. And over here we have y equals negative 2 log of x plus 1. Let's start with the simple ones. Both of them have a horizontal shift. So going from a horizontal shift, this is a shift right by 4 and this is a shift left by 1, which means we have to shift left 5 units. So we're going to automatically write down horizontal translation 5 units to the left. So that's going to be our first point there. Then we look for any other similarities. They both don't have horizontal stretch or compression. They both don't have vertical shift, but they do both have vertical stretch and compression. Main first thing that we see is this one does not have a negative while this one does, which means we need to apply a vertical reflection. And if you don't like writing it that way, we can write in brackets reflection on the x-axis. This is essentially what we're doing. And our last one here is, of course, getting our value from 4 to 2, which will just be a compression by half, because 2 is half of 4. So it'll be a vertical compression by factor of 1 over 2. And there's our answer here. Okay, so let's zoom in a little bit so we can see that a little better. So once you get comfortable like this, none of this is new to you. None of this should be new to you. If this feels new to you, we need to talk. Please email me, and we need to make sure you are comfortable with these transformations. Not trying to point you out or anything, but this is something you've been doing till now since the start of this course, and I think this should be something you are more than capable of doing. Some observations that you should have noticed. The vertical asymptote only changes when a horizontal translation is applied, right? When we look at all of the previous examples, when a horizontal translation to the left happens, then the vertical asymptote shifts. If a horizontal translation to the right happens, then the vertical asymptote shifts to that value. So that one's pretty obvious to identify. For the domain, depending on which way it is facing, right? So if you've applied a horizontal reflection, then your values are going to be less than your horizontal asymptote. If you did not apply a horizontal reflection or reflection in the y-axis, then your values are going to be greater than your asymptote. And so we've been through examples of that. And finally, our range. The range of a transformed logarithmic function is always y is any real number. And that is because we don't have any horizontal asymptotes that restrict our values of y. They will go infinitely in both directions, which means they will be any real number. So that lesson, once again, wasn't a particularly difficult one, but it is very good review for your transformations that you've worked with thus far in the course. Okay? So, does anyone have any final questions before we end it here for today? And then I have a couple announcements to make, like 1 or 2 announcements. Going once, going twice. Okay, so it looks like there are no other questions. So some quick announcements. Number 1, if you have not done so already, please go to the Google Forms to indicate your partner if you choose to have one, as well as the function you would like to research and make a presentation for your culminating project. So please do that. Second, I would like you all to understand that there will be a quiz coming up for this. It might be just like a giant review quiz, because I do want to move on to the next chapters and have you focus on your culminating project. So I'm probably a quick quiz Monday next week. So I'll be preparing it over the weekend. You'll have it ready for Monday. And if it's ready for Monday, then we will not have a live stream session. I'll post an announcement for that. And you'll do the quiz on the Monday. If you can't do it on the Monday, just take the time to do it throughout the week. And we're hopefully going to start our new unit next Tuesday. So that's the goal for next Tuesday. We're hopefully starting our new unit then. All right? So if you have any questions, please let me know. Is it going to be a math space? No, probably not. I do want to see you do your work on a piece of paper and actually show me your calculations and like solving like that. So it'll most likely be just through Google Classroom. I'll upload a PDF. You can either write on it or take a picture of you copying down the questions and upload it onto Google Classroom. Chapter 6 is almost done. We have covered almost all of Chapter 6. The only thing left is your favorite word problems. So we will be going over some word problems tomorrow, as well as general review. So tomorrow's class might be the full hour, depending on how well you guys do on those word problems. Any other questions? Those were very good questions. All right. So that is it. Have yourselves a wonderful rest of the day. Relax. It's a really nice day outside. Go for a quick walk or something. Stay healthy. Get some vitamin D. And I'll see you tomorrow, 2 p.m. Peace out.